Hello everyone, welcome to Tech with Machines. Today we are going to talk about Apache Spark. You would have heard this term a lot of times, and if you are getting introduced first time to distributed computing systems, then Apache Spark is one of the tools which is readily used for distributed computing. In this video, we'll mostly talk about what really is the need or what are the advantages which Apache Spark fulfills. And in the upcoming videos, we'll talk about what is the architecture of Apache Spark, and then we will start with the hands-on coding in Apache Spark with different concepts and examples. So before we understand what Apache Spark really is, let's try to first understand what are the challenges in big data today and why is there a need to have tools like Apache Spark. So first thing is that we majorly will talk about the 5 V's: volume, velocity, variety, veracity and value. Now what these V's generally stand for or refer to, we'll go one by one. So let's start first with volume. Volume is generally related to the growth in the data, which has grown exponentially with the introduction of digital devices, online transactions, social media platforms, IoT devices. So you'll see data flowing here and there from multiple sources. So handling such large volume of data is not something which traditional database management and data processing techniques can do. So for that, we need a scalable and distributed computing system like Apache Spark. So this basically checks one point, that Apache Spark is distributed, is scalable, can handle large volume of data sets which might be too large to be processed using traditional database management systems, right? So big data's first challenge is volume. The second one is velocity. Velocity is also important because as the data is growing, the time it takes to generate that data or process that data is also important. So we generate, we collect, we process. That is what velocity refers to. And we have real-time data streams from sources like sensors, social media feeds, click streams, financial transactions. They actually really require near instantaneous processing. So if we will do traditional batch processing system, that will struggle to keep up with this velocity of incoming data. So it really brings the need of having real-time processing frameworks. And Apache Spark does have a real-time processing framework like Spark Streaming. So I'm just trying to correlate each of these V challenges with the feature of Apache Spark, so that during the course you understand why Apache Spark fits and actually overcomes these challenges in one or the other way. Now the third one is variety. Now with the growing data and the speed with which we need to translate or collect or process this data, there is also a variety. There is data which is in various formats, like there is structured data, there is semi-structured data like JSON, XML, or there is unstructured data like there is free text, there is images, there are videos. Now handling these many various formats or analyzing and extracting insights from these different data types will pose different challenges, or different processing techniques will be required for each type. Now Spark does have ability to handle structured and unstructured data, and which makes it suitable for processing diverse data formats. Then comes veracity. Veracity is mostly related to the data reliability and trustworthiness or accuracy of the data. Now, generally, if there is too much of a data, there will be too much of a noise, incomplete or inconsistent data, which will lead to challenges in data quality and reliability. So you will require data cleaning, pre-processing, quality assurance. These are the essential steps which will require in any analytics workflow, which Spark does support through its data manipulation capabilities. Finally is a value. You basically want to extract actionable insights and have a business impact with the data which you are collecting and processing. So this is generally a primary goal of all organizations which are dealing with big data. Now, analyzing large data sets can uncover valuable patterns, trends, correlations, predictive insights that drive business decisions, and optimize operations and improve customer experiences. Now, Spark has the advanced analytical capabilities, which includes the machine learning libraries like MLlib, and this helps to enable organizations to derive value from their big data investments. So, in nutshell, the traditional tools like relational databases, data warehouses, batch processing frameworks, they have limitations in handling these big data challenges. Distributed computing frameworks like Apache Spark or Apache Hadoop, they have emerged to address these challenges by providing scalable, fault-tolerant, and parallel processing capabilities. So Spark in particular has gained a lot of popularity due to its speed, its nature of easy use, its in-memory processing, and support for diverse workloads. And it can effectively manage and analyze big data, which can lead to several business benefits and improve decision making in multiple organizations. So that's what leads to or appreciate the need for advanced data processing frameworks like Apache Spark, and what role and how they actually play a bigger role in unlocking the potential of big data for businesses and organizations. So these five V's are very important to understand why do there is a need of a distributed computing system or such techniques when there are traditional databases. So I hope this clarifies first, before we go to what Apache Spark is, certain challenges and certain concepts are clarified in details. Now, before we move to Apache Spark or a general definition of Apache Spark, we also want to understand certain distributed concepts which are very important and which Spark does support. Now, these distributed concepts are going to be very important to understand from the term of architectural capabilities as well, or system design capabilities as well, because any framework or any system or any platform which you are building, these distributed concepts may or may not be part of your platform according to your requirement. So these are important concepts to be understood and will help you in your system design and architectural principles as well. So let's deep dive into distributed computing concepts. First thing is parallel processing, because we are talking about distributed computing, so parallel processing comes as a very general concept in that. So what does parallel processing really means? It means basically you should be able to break down or divide a task into smaller subtasks and able to distribute and execute those tasks parallelly or simultaneously on multiple processing units. Now, in distributed computing world, parallel processing is achieved by distributing data and computations across multiple nodes or machines in a cluster, and that's what Spark does provide us. Now, this parallelism will lead to improved performance and scalability because the task will be completed faster and we will leverage the computed and combined processing power of multiple nodes in a cluster, which eventually leads to scalability because you are distributing data, you are able to distribute data across nodes in a cluster, so you can really add resources or add processing power without significantly impacting performance. So such systems are generally designed to be scalable, allowing them to process large volumes of data and handle growing user demands efficiently. Now, Apache Spark does have scalability concept by adding more worker nodes to the cluster, and what worker and master really means in Apache Spark architecture will go through in the coming videos. But Apache Spark does have a capability to increase workloads by adding more resources. That's what scalability refers to. Now, if you are dealing with multiple nodes in a cluster, there's a possibility that there can be failures as well. So fault tolerance as a concept is ability of a system to continue functioning properly in the presence of errors or hardware or software issues, right? So in distributed computing, it becomes critical due to distributed nature of the system, where individual nodes or components may fail independently. Now, Apache Spark does achieve fault tolerance through mechanisms like RDD, which is a basic structured API of Spark, and it allows the lost data partitions to be recomputed from the original source data or intermediate transformations. So fault tolerance is one of the important concept in world of distributed computing. Now comes, because we are doing distribution of the data, so we do need to divide data into smaller chunks so that they can be processed independently and parallelly. So data partitioning is nothing but dividing a data set into smaller partitions or chunks. Now distributed computing does use data partitioning so that they can distribute data across nodes in a cluster, and ultimately which leads to the first concept called parallel processing. Now there is data locality as well, so there should be a capability or a principle of processing data in the system where it resides or is readily available, so that you don't really have to transfer the data or have the overhead of network. And how, if we maximize data locality, it reduces the latency and improves overall system performance as well. So there should be a capability to have data locality as well, where you can actually do handle the data locally if it's readily available. Now, Apache Spark's data processing model aims to achieve high data locality by scheduling tasks on nodes where data partitions are stored or cached in memory, reducing the need for data shuffling and network communication. We'll read about the shuffling and the network overhead in Apache Spark as well. But generally, data locality is one of the features or one of the concepts which Apache Spark supports. Then comes synchronization and communication, because you are dealing with multiple nodes, so you need to ensure that there are the tasks coordinated, the data is shared, and the consistency is ensured. So techniques like message passing, distributed locking, coordination protocols are used to manage interactions between nodes in a distributed environment. Spark's execution engine actually handles the synchronization and communication transparently, so which has an abstraction of basically hiding the complexity of distributed coordination and at the same time optimizing task execution across the cluster. So understanding these distributed computing concepts is essential for grasping how distributed systems like Apache Spark achieve high performance, fault tolerance, and scalability when processing large-scale data sets across distributed clusters. So in general, in nutshell, Apache Spark is a distributed open source computing framework designed to process big data and analytics, and it processes large data sets in parallel across cluster of machines. So now you can see that how these concepts are in a nutshell define Apache Spark. So when you have to actually explain Apache Spark, you can majorly talk about these concepts which Apache Spark offers as features and as capabilities, right? So this is what leads to end of this video. We're gonna talk about the challenges of the big data and the distributed computing concepts. In the next one, we're gonna dig deeper into Apache Spark's architecture and Apache Spark's components. And in the upcoming videos, then we'll talk about the concepts of Apache Spark with the code. Thank you so much. Keep learning.